Okay, so this is the second part of the video. Sorry I couldn't just finish it all in one. Drank some water and such, so maybe I'll get through this last page and I'll be done. This is inverse normal probability distribution. If you're given the area and you're trying to find the z-score or an x data value, because you can use the formula to go back, you're going to use the inverse norm. You can do this on the calculator using second vars and then choosing inverse norm. So if you want to find this, you're looking for this z-score here. So the area to the right's 0.01, the area to the left's 0.99 because they add up to 1. If you want to use the chart, it's sometimes difficult because the 4 decimals are in here. So 0.99 is what you would have to hunt for. So you can go through here and look until you find something close to 0.99, which in this case we'll be at 0.9901 is the closest we can find. Which means our z-score would be 2.33. So when we do going the other way, the chart's easier finding probabilities sometimes, but the calculator's easier when you're going the other way because you're hunting for numbers, and you may or may not find the exact number. You might have to use something close. So on the calculator, what you do is you go to second vars, choose the third one, and you have to type in the area to the left always. So we type in 0.99, which gives us 2.33. For z-scores, always round to 2. If you want the area between two values, this is where it gets a little bit tricky, because the calculator can only handle the area to the left for inverse norm. Or the chart only gives you the area to the left. Either way, you look at it, you only have the area to the left. So between two z values, what you want to do is you'll take, there's some examples to, or pictures that explain this too. What you want to do is you'll take 1 minus whatever the area is given to you in the middle, 0.7814. which is equal to 0.2186. That area is in the two tails combined because the area under the whole thing has to be 1. So if we take the area in the middle away from 1, that gives us the two tails. Well, because it's symmetric, that means half of that, this number is here, and half of it's here. So we take this 0.28 or 0.2186 divided by 2, and you get 0.1093. So this area is 0.1093, and this area is 0.1093. So you could go through on your chart and look for 0.1093 if you wanted, or you can do inverse norm on the calculator. 0.1. And that gives you negative 1.23. And like I said, if you had looked on the chart, because I know what it is now, negative 1.23, you'd have found 0.1093 if you looked for it. So you could have gotten it that way. And that gives you the negative z value. Well, because it's symmetric, for this is negative 1.23. So this one up here must be positive 1.23. For the last one here, area between negative z and z is 99%. So this is 99%, which means if we take 1 minus 0.99, we get 0.01. So that's in the two tails. 0.01 is in the two tails combined. Divide it in half. You can also write this as plus or minus if you want to, by the way, instead of listing it up here. There's two z-scores and it's symmetric, so you could just put plus or minus. But anyways, 0.005. So 0.005 here and 0.005 here. So if you do second vars inverse norm 0.005, you get negative 2.0 2.58. And again, if you look at the chart, negative 2.58, it doesn't actually have, here's where you might want to check it on the calculator, because for 0.005, you don't know if it means 0.0051 or 0.0049, because 0.0051 rounds to 0.005 and 0.0049 rounds to 0.005. So this is where I would do it on the calculator and round based off the calculator rules. So we would use negative 2.58. And again, if this is negative 2.58, this has to be positive. So you could just drop plus or minus. An application of this, you have the verbal SAT test has a mean score of 500, standard deviation of 100, so there's mu and sigma. They're normally distributed. Major university only accepts the top 4%, so you want to know what's the minimum score that you need if you want to get in. So, what we want to know is, what do we have to be in this top 4%? So we want to know what is X really, because we need to know what is our data value. Do we have to score a 700? Do we need to score a 600? Whatever. And in order to find X, we would need to find Z. So if this is 4%, this down here is 96%. So Z is equal to the inverse norm of, you always have to put in the area to the left. So you can put in 0.96 or you could type in 1 minus 0.04, either one, but it has to be whatever's to the left. So that gives us 1.75. So Z is 1.75. Don't say the answer is 1.75. The answer is 1.75 standard deviations above the mean. So you have to remember to convert it back. It asks you what's the minimum score. Say I'm telling somebody they have to score 1.75 standard deviations above the mean, probably not going to mean a whole lot to them. So going back to our formula, X is equal to our mean, or I think I have Z sigma first. Well, whatever, it doesn't matter. 1.75 our Z score times our sigma, which is 100, plus our mean. I believe that's how I wrote it. That gives you 675. So you have to score a minimum of 675 in order to get in to that university, to be in the top 4%. So just a couple additional examples. These are on the PowerPoint. Pediatrician obtains the heights of her 203-year-old patients, female patients. They are normally distributed with a mean of 38.72, standard deviation of 3.17. What percent of the 3-year-old patient females have height less than 35? So what percent, and pay attention, if it says percent, you switch to percent. If it just says probability, you can leave a decimal. Probability that X is less than 35. And I should also make a note, if you had a less than or equal to, you typically don't see that, but the vertical bar, when we draw these bars, that's the equal to. They don't have an area, so you do them the same way, but generally it's always strict inequalities. So what we would want to do is convert it to a Z. So Z is equal to our X, which is 35, minus our mean, 38.72, divided by our sigma of 3.17, which is equal to negative 1.17. And you can draw this if you want. Let's see, here's our mean of 38.72. Or 0, depending on which one we're talking about, and this down here would be 35, and we want the area to the left of that. So on the homework, I think it says to sketch, so that's what it would mean. Just draw a picture, show what you're finding. So this is the same as the probability that Z is less than negative 1.17. Go to the chart or the calculator, look it up. You should get 0.1210, but it says what percent, so that would be 12.1%. Between 35 and 40, if you're between 35 and 40, well, 35 we just did, so we don't have to do that again. So the Z for 40 minus 38.72 divided by 3.17 is equal to 0.4. So this is the same as the probability of z being between negative 1.17 from this one. So for this one, remember you have to take the bigger z value, the value on the chart for that, minus the smaller one to get the area between. So we're going to, if you do that, go to find the value for 0.4, subtract off the value for negative 1.17, you should get 0.5344. And for that one, if you drew a picture, you would draw between, it would be, let's see, 40s here. There's 40. Let me just start. That would be the middle area there. Find the z-score such that the area to the left, oh, and this one just says probability, so you can leave the decimal. So only time to change to percent is if it asks for the percent. Find the z-score such that the area to the left is 0.32. So we want to find the z-score so that the area over here is 0.32. So you can go on the chart and look, but again, this is one where you might want to at least check it on the calculator. Do second vars, inverse norm, 0.32. You should get negative 0.47. Yeah, negative 0.47. The area to the right of the z-score is 0.4332. Let's hold my paper down. And you should kind of know where these lines go, because remember, if you cut it in half, it's 0.5. So depending on what it's talking about, you can kind of guess about where the line goes. So if we went to the right of 0.4332, well, to the right of this line would be 0.5, so just scoot it over a little bit. So our z is inverse norm of 1 minus, because you have to do the area to the left. So 1 minus 0.4332. And you can type that just like that on the calculator. Second vars, inverse norm, 1 minus 0.4332. And it gives you 0.17 for z, because z you round to 2. So that's normal distributions for the notes. I have another examples video that I need to make. I don't know whether to try to make it today in case I have another coughing fit. Oh, here's the calculator notes too, just so you can see. If you want to use the calculator, that is. So I might just maybe wait out through the weekend and see if my voice sounds better and I don't cough so much, and then I'll post the next video at the beginning of next week. But this is notes, so you can at least get started on homework if you want to get started this weekend. Just let me know if you have any questions.